So last week, the second day of modulus, the second day of modulus functions, and then we discuss about solving modulus inequalities. And I told you there are two main ways to solve modulus inequalities. So one way is the graphical method, silence. One way is the graphical method. Yeah, we will be sketching the graph of the modulus functions. And then we will be using the diagram Cartesian plane to solve the inequality. So that is the main way, the main method that we will be discussing under this lesson. Because the reason I told you, if you go to the last 6 years of the passport questions, you will realize that beginning of every question, we are supposed to sketch the diagram. So first one is that you are supposed to sketch the function on the modulus graph, and then only you are supposed to solve the inequality. So that is the main thing that we are discussing here. But next week at the end of the lesson, I'll be even explaining you how to solve and modulus inequality using the algebraic method. So last week we did few questions, including two of the aspect questions. But so far, what we have done, when we have a modulus function in one side, and the other side, it's a normal straight line. So that is what we have done last week. We have considered the modulus function in one side and the straight line on the other side. Today we will be discussing modulus inequalities where we have the modulus in both sides. So it's the modulus in both sides. It's the same thing. Let's slowly come to that step. How can we solve the modulus inequality? So inequality consists of a modulus. Okay, so remind last week's work. Start with 1996. Sure. Remind last week's work. Start with 1996. Question number 6 on the past papers. So 6. Question. We're supposed to solve this. Do that. Modulus 3x minus 4 is greater than 2 minus 5x. Greater than 2 minus 5x. So what are the graphs that we are supposed to sketch? One is y modulus 3x minus 4. So here we have 3x minus 4 and minus 3x plus 4. So we have done this last week. Because in first we will be sketching the modulus graph. X minus 3x plus 4. And this is when x is greater than 5, and this is when x is less than 4. So what are the straight lines that you have to sketch there? So y is 3x minus 4.
And the other one is y equals minus 3x plus 4. And then even we have to sketch the graph of y equals 2 minus 5x. So if you can remember, last week I told you how to sketch the graph using only one point. So in this one, I told you to consider the turning point. The turning point is 4 over 3. And when you substitute 4 over 3, you get 0 here. And even here, the turning point is the same, 4 over 3. When you substitute 4 over 3, you get 0. And then when you're sketching this one, you have the intercept that we can sketch later. So now let's consider these two graphs. Y equals 3x minus 4. Y equals 3x minus 4 and minus 3x plus 4. So what is the turning point? The turning point is 4 over 3. So at 4 over 3, Here we got y equals 3x minus 4. So the gradient is 3. And it's clear that it goes through this point, the gradient is 3. So when you are sketching a straight line with a gradient 3, make sure that the next gradient is something like 5. So I know normally when we are taking a gradient like 1, 2, and 3 is more inclined, but we need to make sure that the next gradient is minus 5. So that one will be more inclined. And then in the other hand, minus 3x plus 4 is having a gradient of minus 3. It's in this way. It's having a gradient of minus 3. So then you can sketch this in this way. Here it becomes 4 because the intercept is 4. So here it's y equals minus 3x plus 4, and here it's y equals 3x minus 4. And then in this case, when you are supposed to draw y equals 2 minus 5x, you can start from the intercept. The intercept is 3, sorry, the 2. But here it's clear that the gradient, if you consider the gradient is minus 5. So if you take a gradient like minus 3, the two lines will be parallel to each other. The two lines will be parallel. But when it is minus 5, the gradient, like the line should be more inclined. If you go with a gradient like minus 3, it's parallel. But minus 5 means it's more inclined, which means from here it goes in this way. And this one, it's not parallel, it's more inclined. So you get the straight line in this way. So this is the straight line y equals 2 minus 5x. And you have to find the point of intersection because I told you that is the point which changes the inequality. Find the point of intersection. What are the two lines that have been intersected here? Y equals minus 3x plus 4 and y equals 2 minus 5x. So when you make these two equal, minus 3x plus 4 is equal to 2 minus 5x. You get 2x is equal to minus 2, so x is equal to minus 1. So you get the point of intersection as minus 1. First find the point of intersection and then look at the inequality. You're supposed to find that the modulus function is greater, which means the black colored one is greater. But if you consider this, it's clear that the black colored one is below the blue colored one. So when it is below, it means it's less than. So here the black colored one becomes greater after this point of intersection. It's clear after this point, the black colored one is always above the blue colored one. The black colored lines are always above the blue colored one. So then the inequality is that x is greater than minus 1. So we can write the final answer. 3x modulus 3x minus 4 is greater than 2 minus 5x when x is greater than minus 3. Sorry, when x is greater than minus 1. You get the answer when x is greater than minus 1. Okay, hands up who got that answer. Okay. Okay, now what I want to do is start this question number 7, and first write the definitions of the two graphs. Start question number 7 and in the first page, question number 2, start the question number 1. First write the definitions of the two modulus. Silence. Start the question number 7 and the main question 2. Because previously the voice was not that clear in the YouTube live. Can you send me a message to the online students mentioning whether the voice is more clear enough? Now can you send me a message in the chat? Okay, so question number 7, what you got is you're supposed to solve the inequality that x minus 1 is greater than x plus 1 modulus. X minus 1 modulus is greater than this. So when you consider the definitions of the modulus functions, you have y equals this. So it gives you x minus 1. So we have separately drawn these two and minus x plus 1. So this is when x is greater or equal to 1, and this is when x is less than 1. And if you write the other inequality, it's x plus 1 modulus, you get x plus 1 and you get minus x minus 1. So this is when x is greater than or equal to minus 1, and this is when x is less than minus 1. So what are the, now here in this case, you are supposed to sketch 4 straight lines, y equals x minus 1, y equals minus x plus 1, and then y equals x plus 1, and then you got y equals minus x minus 1. So find one point that's sufficient. I told you to go ahead with the turning point. So when you put x equals 1, when you put x equals 1 here, you get 1, 0. Here it's even 1, 0. For these two straight lines, what is the turning point? It's x equals minus 1. So when you put minus 1, you get 0 and you get 0. So same thing that we have drawn these two modulus graph separately on two Cartesian planes. We have drawn the modulus graph separately. Now what you have to do, you have to draw this on the same Cartesian plane. That's all. What you have done separately before, now you have to draw this on the same Cartesian plane. So when you draw this on the same Cartesian plane, so let's start with this one. I told you 1 point is enough. So I'm using x is equal to 1, this point, and this is 1, 0. So that is x minus 1. So from here, you have to draw the graph which has a gradient of 1. And here, you have to draw this graph which is having a gradient of minus 1. And here it's clear that the intercept is 1. Soon after you draw them, name the graph y equals x minus 1 and y equals minus x plus 1. And now when you sketch these two, this is x plus 1. So at minus 1, it's 0. It's 0, having a gradient of 1. So I know when the gradient is 1 and the intercept is 1. So when you are drawing these straight lines, you have to consider the small details. So what are the details that you have to consider? The intercept, because then it is clear even the intercept here is plus 1, and even the intercept of this graph, that is even plus 1. So those are the small details that you have to consider. And then in the other hand, it's clear that the two gradients are equal. So when the two gradients are equal, I know that the two straight lines will be parallel. So you have to consider that, because let's say that you are not sketching this in a parallel way, which means you get a point of intersection. That is wrong. If you don't draw these two straight lines parallel to each other, let's say you are inclined one. So then it's clear that you get a point of intersection. It's wrong. Because we know the main story of these inequalities is based on intersection points. Because when we get intersection point, the modulus inequality or the logic changes. So you have to make sure about that. So, and that is, there are no any parallel lines there. And in this side, when you consider minus x minus 1, it is having a gradient of minus 1, which is parallel to this. Which is parallel to this. Even it is parallel, no any intersection, and this is y equals minus x minus 1. And when you look at this, it's clear. When you look at this, the question that they're asking that x minus 1 modulus is greater, which means the black colored one is greater. And it's clear there's only one intersection point, which is 0. Only one intersection point. Okay, so it is 0. And it is clear. In this region, you can see that the black colored one is greater. But after this point of intersection, the blue colored one is going above, which means the blue colored one is greater than the black colored one. So here, in this region is where you get the black colored one is greater than the blue colored one. So you can write the answer, the final answer, modulus x minus 1 is greater than modulus x plus 1 when x is less than 0. when x is less than 0. So this is inequality. At this range, it will be less than 0. Clear? Okay, hands up who understood this. Okay, so now what I want you to do in this way. Like, if you are more comfortable with this method, you can use this method. But we need to even know about this one. So this is a first part question in your pure maths paper. In your A-level paper, this comes as the second one, second paper, second question. So when it is a first part question, you only get 25 marks out of 1000. Pure maths paper ගේ ලකුණු 1000න් මේකට 25යි යම්මෙන only you get 25. So when you get 25 marks, normally in a first part question, you get 5 steps where 5 marks have been allocated. So 5 into 5 gives you 25. එනවාට steps 5ක් තියෙනවා එක step එකකට 5 ගානේ තමයි 25 හම්බෙන්නේ. So in this one, you get 25 marks in this way. Pearly sketching this straight line, you get 5 marks. This straight line, you get 5 marks. This straight line, you get 5 marks. And this straight line, you get 5 marks. And for the final answer, you get 5 marks. So here, normally you get 5 and 5, but let's say that you are supposed to find 2 intersection points. අපි කියමුකෝ දැන් ඔයාලට intersection points දෙකක් හොයන්න තියෙනවා. You're supposed to find 2 intersection points. In that case, you only get 5 marks for this graph, 5 marks for this graph. Finding the 2 intersection points, you get 5 each n, and for the final answer, you get 5. So why did I highlight this factor? Is because for this entire thing, you won't be getting any mark. For this entire, write in the definition, find in the coordinates, you won't be getting, none of the marks will be allocated. So write in this one is only up to you. So that's what I'm telling you. If someone can directly sketch the graph without writing any of this, you have the freedom to do that because you won't be getting marks for this part. But I don't want everyone here to try in that way. First, let's do in this way, get used to this. And then we can just skip this part. And when you have to draw this one, you can look at this, find the coordinate of the turning point, and directly you can sketch the graph. But for now, if you are like, you need this, you need the support of these small things, you can go in that way. But if there's anyone who can directly sketch the graph without writing any of this, you have the freedom to do that. Is it clear? Because I wanted to highlight in the A-level exam, you won't be getting marks for any of this part. Clear? Okay. මුලින්ම මෙහෙම කරමු. පස්සේ we can skip this part and then do that. Okay. Is that clear? Okay, then let's do the next question. Do question number 8. Both question number 8 and then question number 9. So for both question number 8 and 9, since we are having the same modulus graph, you can directly draw this, or you can just use it. Because we will be using the same one. So no need of writing the definition again and again and finding the points. So both 8 and 9, just directly take this graph. Y equals x plus 1 modulus. Okay, so let's do question number 8. Here, we are supposed to solve x minus 2 is greater than x plus 1. Okay, so I told you I want you to use that previous graph that we have taken. So only write the definition of y equals modulus x minus 2. So that is x minus 2 when x is greater or equal to 2. And you get the minus. So it's minus x plus 2 when x is less than 2. So what are the two straight lines you have to sketch? It's y equals x minus 2 and y equals minus x plus 2. So you're supposed to sketch these two straight lines. So find the turning point by substituting the x value, x equals 2, you get 0, 2, 0. And even here you get 2, 0. Okay, so now sketch the graph in the same Cartesian plane. 1 is having a turning point at x equals 2. So if you take this as 2, x minus 2, the gradient is 1, it goes in this way, and minus x plus 2 is even having a gradient of minus 1 going in this way. So here the intercept becomes 2. So I told you those things will be small things, but you can use them. Y equals x minus 2 and y equals x minus x plus 2. And then just repeat the same graph. You don't have to write the definition again. It's starting from minus 1 and the intercept is 1 and it should be going parallel to this one. So it's parallel because both are having the same gradient. Y equals x plus 1. Both are having the same gradient. And even here, both are having the same gradient. It's minus x minus 1. So it's clear that you got one intersection point. Find the intersection point. So what are the two straight lines that have been intersected? Take them properly. Y equals x plus 1 has been intersected with y equals minus x plus 2. So we get x plus 1 is equal to minus x plus 2, which means 2x is equal to 1, x is equal to half. So your intersection point is half. And then look at the inequality. You're supposed to solve that x minus 2. The black colored one is greater than the blue colored one. So it's clear in this region that the black colored one is greater. Only after this point of intersection, the black colored one is going below the blue colored one, which means it's less than. So then you can write your final answer that x minus 2 modulus is greater than x plus 1 when x is less than half. Only when x is less than half. Hands up who got this one, that x is less than half. Okay, good. Students who have online, even joined online, send me a message. So when I ask a question, who understood and who got the answer, the online students even respond because I can't ask them separately. So you can even respond whether it is clear, whether you have got the correct answer. Okay, so question number 9 is the same thing, but 2x minus 1. So here we are having a gradient change. 2x minus 1 should be greater than this. So here, write the definition. Y equals modulus 2x minus 1. You get 2x minus 1 when x is greater or equal to half. You get the minus of it when x is less than half. So what are the two straight lines that you're supposed to sketch? Y equals 2x minus 1 and y equals minus 2x plus 1. So I'll be doing in the same way. I won't be like next week when we are drawing the graph, I will be directly sketching the graph. But today I'll be totally taking writing the definition and finding the points and doing it in a way that everyone can understand. So if you put x equals half, this becomes 0 when you go with x equals half. Even this becomes 0. So what is the graph? 2x minus 1. So first let's sketch the graph that we know. X plus 1 modulus. So it goes through this minus 1 and having a gradient of 1. So this is y equals x plus 1. And then this is y equals minus x minus 1. Clear. And now we are going to draw this one, y equals 2x minus 1. So here it's clear. You don't have to think about the intercept. You're going to sketch y equals this. But I know that the gradient here is greater. So how can you think when the two gradients are equal, the two lines are parallel. When the two gradients are equal, the two lines are parallel. So when the gradient is greater, means the inclination is more greater than this one. So there should be a clear intersection. There should be a clear intersection. So soon after you draw this, name it y equals 2x minus 1. And next one is y equals minus 2x plus 1. For that one, you can get help of the intercept. It's clear that it is going through the same intercept. And since the gradient here is minus 1 and the gradient here is minus 2, it's clear that these won't intersect again because here it's going in this way, here it's going in this way. So there are two intersection points. One that they have been intersected here, and the other one that they have been intersected at this point. So they have been intersected at this point. Clear. So this one you can find it at 0. Find this point of intersection. What are the two straight lines that have been intersected? Y equals 2x minus 1 and y equals x plus 1. So you get 2x minus 1 is equal to x plus 1. So here you get that x is equal to 2. It's 2. Yeah. So the other intersection point is 2. And then look at the inequality. The blue colored one should be greater. Or the blue colored one. It's clear that in this region that the blue colored one is greater because it's going above the black colored one. In this region, the blue colored one is going above the black colored one. In this region, the black colored one is greater because it's above the blue colored one. Again, after beyond this region, beyond this x equals 2, it's clear that the blue colored one is greater than the black colored one. So then you can write the final answer 2x minus 1 modulus, it's greater than x plus 1 when write the two inequalities. X is greater than 0 or x is less than 0 or x is greater than 2. Okay, hands up who have drawn the two graph properly and got this in it. Okay. Then do this one. Question number 11. Question number 11. So when you are doing question number 11, use the same 2x minus 1 modulus graph. You don't have to write the definition again. When you're doing question number 11, use the same 2x minus 1 modulus. Same graph. So question number 11, I told you to use the same 2x minus 1 modulus graph. So then we only have to write the definition of modulus x plus 1. Okay, so question number 11, we got 2x minus 1 modulus. This is greater than x plus 1 modulus. So here, we'll be using the same one. So let's write the definition only for this. Y equals modulus x plus 1. So when x is greater than 0, you are getting directly x. And when it is minus, you get minus x. This is when x is greater than 0, and this is when x is less than 0. So what are the two straight lines that you're supposed to sketch? Y equals x plus 1 and y equals minus x plus 1. So we need to find the turning point, which is also the intercept here, because if you put x equals 0, you get 1, and even here you get 0, 1. So then let's sketch it. The turning point is 0, 1. So it is going through this point. And from this point, draw the straight line, which is having a gradient of 1, which goes in this way, and minus 1, which goes in this way. So you can name this. This is y equals x plus 1, and you can name this. Okay, this is y equals minus x plus 1. And then on the same Cartesian plane, just draw that one, y equals 2x minus 1 modulus. For that purpose, you can use that the intercept here is even 1. So when it is 2x, it's clear this is x. So 2x means the gradient is 2, which means the inclination should be greater. So there is a clear intersection point. So there is a clear intersection point here. But in this case, what happens? When it goes through, it is having a -2 gradient. So here the gradient is -1. So clearly the gradient should be greater than this. But you can take the help that the intercept is +1. So -2x +1 goes through this. So this is y equals -2x +1. Clear. And then first find the intersection points, and then you can think about the inequality. Mulimara intersection points to go well in there. So this intersection point, if you find this, you will be getting, okay, write the equations. Y equals 2x minus 1. So this becomes x equals 2, no? You are getting the intersection point of x equals x. Yeah, 2. And then look at the inequality. The blue colored one should be greater. The blue colored one is greater. It's clear in this region. The blue colored one is greater. And after this one, the black colored one is greater. Again, after this intersection point, the blue colored one is greater. So you get the answer that modulus 2x minus 1 is greater than modulus x plus 1 when arrive the shaded region x is less, same answer. Yeah, same answer. X is less than 0 or x is greater than. Okay, so hands up who got this, sons? Wait, hands up properly. Who drew this two modulus functions? Okay. Okay. So here, okay, I'll just give 1 minute if there's anything note down. Okay, so this thing, okay, now listen. So now we are in the third day of modulus functions, and next week we will be completing all the today even we will be doing many past paper questions, but next week we will be completing the lesson, and even next week I'll discuss about this I'll discuss about this algebraic method. So here, like, still I didn't come and check your books, but I'm sure, pretty sure when I just come and walk and check your books, I'll see these kind of mistakes. One thing that we need to know, so when these two straight lines, when you are sketching these two straight lines, after sketching the first one, and when you are moving to the second one, you know that the gradient is greater. So before sketching this, you know that there is intersection. So you have to draw the second straight line with the intention that the two straight lines will be intersected. If not, I have seen students doing in this way. Okay, now this is the book, Meda Potha. So here we have the modulus function x, this one, this x plus 1. And then you are drawing this blue colored graph. You are drawing this blue colored graph, and then you realize that you won't be able to make them intersect. Then you draw in this way, but you know clearly you can see that the two graphs will be intercepting each other. But now you realize that when you are going in this way, if you continue, you won't be able to show that intersection. So what some students do, they draw the straight line in this way. I have seen, okay, even when I come, I'll just show you some of the students doing that way because they realize there is a point of intersection. And then they do this in this way. So these are straight lines. So this is wrong. And the other thing is some just stop in here and they write, okay, they are intersecting. So where they are intersecting, we have to show the intersection point. So here, make sure before drawing the second line, always it goes with the second line, have the intention whether they are intersecting or not. So based on that, keep your ruler in that way. So if you want to make them intersect, you can keep the ruler here and then you can draw in this way. Okay. Okay. Then do this one, the 2016 past paper. Question number 17, 2016. 2016 past papers and online students, if you're having any doubts, you can directly send a message in the YouTube chat. So when I check it, I'll explain that. If you're having any doubt, you can use the YouTube chat. So modulus x plus 1, you can use the same one. I don't know whether I'm too late to tell that, but you don't have to write the definition. You can use the same graph used in question number 11. Okay, so first, write the definition of this. Y equals 2 times modulus x minus 1. So you get 2 times x minus 1 when it's greater than 1. So this one should be positive. So 2x minus 2, and here you get the minus. So you get minus 2x plus 2 when x is less than 1. So what are the two graphs that you're supposed to draw? Y equals 2x minus 2 and y equals minus 2x plus 2. So find the turning point when x equals 1. You get 0. Even here, when x equals 1, you get 0. So based on that, draw the graph y equals 2 times this. So it's minus 1, 0 going through this point. And the gradient is 2. And the next line is having a gradient of 1. So make sure you are drawing this with a higher inclination because the next one is having a gradient of 1. Okay, so this is y equals 2x minus 2. And then minus 2x going through this point, draw a straight line that is having a gradient of minus 2. So you can use the intercept is 2 here. Okay, this is y equals minus 2x plus 2. So it's y equals minus 2x plus 2. So I told you to use the same graph modulus x plus 1, which is going through this point 1, and it is having a gradient of 1. So it's clear when if the two gradients are equal, the lines are parallel. But here the gradient is 1. So here the gradient is 2, which means the line should be less inclined. So it's going in this way. It's going in this way. So I told you, you should have the intention when you are sketching the straight line, okay, this one should be intersected. So there, it should be intersected. Because when it is parallel, if it is parallel, there is no intersection points. But it's not parallel. The gradient is 1. So a gradient is 1 means the inclination is less. It goes in this way. Meanwhile, in the other hand, there is no any intersection because here the gradient is minus 1. Here the gradient is minus 2. So minus 1 means the inclination is less than this one. So here there is no any intersection. Clear? So you have to find intersection points. Two intersection points. Okay, so I'll find one intersection point here. Y equals x plus 1 has been intersected with y equals minus 2x plus 2. So when you make them equal, you get x plus 1 is equal to minus 2x plus 2. This is equal to 2 minus 1. You get 3x is equal to 1. So x is equal to half. So x is equal to, sorry, not half, 1 over 3. And this one, you're supposed to get that the intersection point is equal to 3. And then check the inequality, the blue colored one should be greater. A blue colored one should be greater, and it's clear it is greater within this range, in between 1 over 3 and 3. So then you can write the final answer that x modulus x plus 1 is greater than when, stop talking, x is greater than 1 over 3 and less than 3. Okay, so even this is the way that you get past paper questions. Hands up who got this one. Okay, then come back to question number 2 in the tute. Do question number 13. Question number 13. If there's anything unclear, you can ask from me. So make sure you draw the y equals modulus x minus 2 minus 1 graph properly. Like most of the graph that I have seen, it's wrong. Because that graph is not on the x-axis. It's going below the x-axis. Because when you substitute the turning point x equals 2, the y coordinate is minus 1. So the turning point is 2 minus 1, not 0. So it's not starting from the x-axis. It's going below the x-axis. You can't remember, just turn your book and look from question number 7, 8 that we have done last week on the first question. You can check how we have sketched the graph of, we have sketched the same one, question number 7 and 8. You can check that. Silence. So if there's any question, you can just note them down, and when I come, you can ask. And even online students who have joined online, you can use the YouTube chat to ask a question regarding the lesson. And I saw a question that someone had asked, when are we starting the second part of trigonometry? So second part of trigonometry will be starting next month. We are doing vectors, and in November, since it's the vacation, we'll be doing 2 free seminars to cover logarithms and coordinate geometry. And then after, we'll be doing the second part of trigonometry. Okay, so question number, what was the question? 13. Why now? Okay, so here we have x plus 1, question number 13, modulus x plus 1 is less than x minus 2 minus 1 modulus. Okay, silence. Huh? So here, now this one you can rule. And now when you write the definition of this, so you get directly x minus 2 and you get x minus 3. Here it becomes minus to give you minus x plus 1. So I see when I just look at your books, there are some students who directly write these. That's really good. So that is what even I'm expecting. Step by step, you have to come up to that stage where you can directly write these two. Directly get these two answers. Then x is greater than 2 and when x is less than 2. So now look at this. The two straight lines that you are supposed to sketch is this and this one. So if you put the turning point, this x equals 2, it's minus 1, which means it's not 2, 0. And even here, when you put 2 minus 2 plus 1, it's minus 1. So it's 2 minus 1. You get 2 minus 1. So when you get 2 minus 1, now look at this. First, draw the graph that you know x plus 1 modulus, it goes through minus 1 and it goes in this way. First, draw that one. Okay, this is y equals x plus 1 and minus x minus 1. That is the graph we know. And now look at this. Now we have to draw the straight line. Y equals x minus 3 and the turning point is 2 minus 1. The turning point is not 2, 0. It's 2 minus 1. Right? It's 2 minus 1. So what you have to do, you have to draw a graph y equals x minus 3 having the gradient of 1 going through this point. So when the gradient is 1, it's clear even here the gradient is 1. Even here the gradient is 1, so it will be going in this way, parallel to each other, no any intersection points, because the two lines are parallel. And from here, it should be a gradient of minus 1, and here you can get the help. So that's why I told you, these are the small details that you need to use. The intercept here is plus 1. The intercept here is plus 1. Now you have to draw a graph going through this point with a gradient of minus 1, which means parallel to this. You can get the help that the intercept of that straight line is 1, which means it's going through these 2 points. It's going through these 2 points. And there is no any intersection because the 2 lines are parallel. No any intersection because the 2 lines are parallel. And then there's only one intersection point 0. You're supposed to find that this one is less than this. So the blue colored one is greater only in this region. Blue colored one is greater in this region. After this one, you can see that the black colored one is going above the blue colored one. So this happens when x is less than 0. So I need you to make sure that you are using these small details. The intercept is 1. The 2 lines are parallel, so there are no any intersection. The 2 lines are parallel, so there are no any intersection. Okay, hands up who understood this properly, who understood this. Okay, so now you have to realize when you have to draw, okay, now look at this. When you are drawing something directly a modulus, only a modulus kenek vitarai na. Okay, mega. So when you are getting only a modulus, the graph is every time starting from the x-axis. It's in this way. So when it is a modulus, just turn the page and you can see turn the pages. Every modulus graph, when it is simply a modulus, the graph starts from the x-axis. But if it is a modulus plus 1, plus 2, plus 3, what happens? The previous one, in 2016, we got that. So when it is a modulus plus 1, what happens? This graph goes up. Look at the 2016 one. Modulus x plus 1, it's somewhere here. So when it is modulus plus some 1, the modulus graph goes up. Similarly, when it is a modulus minus some 1, the graph should come down. So if you know that when you are drawing this graph, you don't do that mistake. You will not be doing that mistake because before sketching this, you have this, okay, this one is modulus minus, so it will be coming down. So when it is modulus minus, it comes down. And if you can remember, when there is a minus coefficient in front of the modulus, what happened to the graph? What happened to the graph? The V-shaped graph was mirrored in the opposite way. So when it is, when you have a minus in front of the modulus, the graph should be in this shape. Clear? So those are small things. If it is directly a modulus, whatever the graph you have, it will be starting from the x-axis. It is on the x-axis. But if it is a modulus plus someone, it goes up. When it is modulus minus, it comes down. Clear? It comes down, and then when you have in a minus modulus, a minus in front of the modulus, you are getting this opposite V-shaped graph. Hands up if that is clear. Okay, I'll give you 1 minute. Drink some water. You look so sleepy. So somehow you have come to the class. I know if you went home like after school or if you didn't come to the class, it's a really good environment, climate to sleep. Maru climate එක නිදාගන්න. Even the temperature, humidity, all are set වෙලා තියෙනම නිදාගන්නවා. It's like a natural AC. But somehow you have made a commitment and you have come to the class. No? So don't come to the class and don't sleep. Then you have committed the class and even you sleep. එක්කෝ ගෙදර ඉඳලා නිදා ගන්න තිබ්බාද online කට්ටියත් ගොඩක් ඉන්නවා නිදිමත කට්ටිය. Like the count in the online class is higher than the normal class, so that means එන්න කම්මැලි පැත්ත. Because I don't believe ගම් වතුර දාලා යට වෙච්ච කට්ටිය නෑ එන්න විදියක් නෑ කියලා. එහෙම කට්ටිය නෑනේ. So somehow you have made a commitment and you have come here. Don't come here and sleep. Okay, drink some water, drink some. හැමෝම බොන්න වතුර තියෙන හැමෝම බොන්න. If you have a water bottle, drink some water. ඒ වතුර දෙන්න බොන්න. ඕමි ගන්න නෑ. බොන්න වතුර බොන්න. Everyone, drink some water. Okay, now to question number 15 and first to 15. Silence. The same set of questions. Question number 2. No. Silence. Okay, now finish. Question number 2. Sub question 15. Now stop talking to the question. Question number 15 in the first page of modulus functions. So always know the shape of your modulus function before you sketch it. So when it is 2 minus modulus x, you know that you are getting a, in like you can say that the V shaped has been mirrored. So before drawing the modulus graph, know the shape. So then that makes things easier. Okay, so y equals modulus x is the first modulus graph that we sketched, no, so that you know. Silence, silence. So 2 minus modulus x, you get 2 minus x, and this minus minus becomes plus based on whether it is positive or negative. So you have to draw y equals minus x plus 2 and y equals x plus 2. But I know that the inequality is changing, the direction changes. So here when you put the turning point x equals 0, you get 2, and even here you get 2. Can now sketch the graph. Y equals 2 minus modulus x. And it's clear that it goes through 0 to so this point. So that's why I told you it's easier if you know what is the shape that you are supposed to get. So here you get this minus x plus 2. This is valid when x is greater than 0. So minus x plus 2 is going in this way. But it is only valid when x is greater than 2. So that means starting from here, minus x plus 2 goes in this way. You know that you are getting this shape even before you sketch the graph. So that is the main thing. The next one is x plus 2. The x plus 2 graph is in this way, but it is only valid when x is less than 2. See, this is only valid when, x is less than 0. So here it goes in this way. This is only valid when x is less than 0. When it is less than 0. That is y equals x plus 2. So when you know the shape, okay, I have a minus here, which means I'm getting an inverted graph, then that's easier because even when you draw the straight lines, you know the two areas, the two parts that will be erased is this part and this part. And then y equals modulus x, the easiest one. Y equals modulus x is y equals x, parallel lines, and y equals minus x, parallel lines. Y equals x and y equals minus x. So that is the very first modulus graph you have sketched. No? So find the two intersection points and you get this is plus 1 and this is minus 1. You get the two intersection points plus 1 and minus 1. And then look at the inequality. You are supposed to find modulus x is greater. The blue colored one is greater. Okay, the blue colored one is greater in this region. And in this region, the blue colored one is greater. Modulus x. Okay, so then you can write modulus x is greater than 2 minus modulus x when x is less than minus 1 or x is greater than minus 1. So you get that this is happening when x is greater than minus 1 or greater than plus 1. Less than minus 1 or greater than minus 1. Greater than 1. Okay, hands up. Who got these sons? Yes, I'm getting. Good. So let's do one more question from the tute and then we can complete the past papers. Do the 16th question. Question number 16. Okay, so here I have this 2 minus x minus 1 modulus. So it directly comes out, you get this. So here when you simplify, it's minus x plus 3. When it is minus minus, it becomes plus. So here you get x plus 1. So this is valid only when x is greater than 1. This is valid when x is less than 1. So y equals minus x plus 3 And the other straight line that you're supposed to draw is y equals x plus 1. So always know the turning point, that is the most important point. When x equals 1, you get 2, and when x equals 1, you get 2. Okay, so then mark it on the Cartesian plane, but before even sketching the graph, you know it is a minus modulus, which means you are getting a opposite graph. So when x is equal to 1, okay, y is equal to 2. So it's from here. And if you draw y equals minus x plus 3, which is only valid after x equals 1, it goes in this way. So this is y equals minus x plus 3. And then x plus 1, but only valid when x is less than 1, it goes in this way, having an intercept of 1. And this is 2. Y equals x plus 1. And then the easiest graph, y equals modulus x parallel to this one, because the gradients are equal. And even here it goes in this way. Y equals x, y equals minus x. Two intersection points. Find the two intersection points that you can do. So I'll find one intersection point. Let's find this one. So over here, when you find it, it's y equals x plus 1 is equal to y equals minus x. So you get 2x is equal to minus 1, so x is equal to minus half. So this intersection point is x is equal to minus half. And this intersection point is x is equal to 3 over 2. And you're supposed to find the region that the black colored one is greater. It's clear that the black colored one is greater in this region. The black colored graph is great in this region. Got it? Okay. So then you can write the final answer. 2 minus modulus x minus 1 is greater than modulus x when x is in between this minus half and 3 over 2. Okay, hands up who got this one. Okay. Okay, so let's write the story that what not a story, what I gave about this graph as a note. So write in a red pen, just write this note. And then it's clear that you have idea before sadhana before sketching the graph, you know that what is the graph that you should end up with. Okay, so here, this one, it is y equals modulus sum 1. So just write y equals modulus sum 1. So I'll write in this way, if not, it's wrong. Modulus, let's say x plus a. And this graph is when you are having a modulus, the coefficient is minus this one. The graph goes up when you have a modulus plus something, plus, let's say, plus k. And the modulus goes down when it is a modulus minus. Modulus minus, it goes down. Let's do one more. If you have this minus modulus plus someone, y equals minus modulus, okay, and then you have in plus someone. Then it comes up. So these are normally the shapes that you get based on the modulus function. So when it is a modulus, only a modulus, it's always starting from the x-axis. But when it is a modulus plus, it goes up. Modulus minus, it comes down. So this one has gone up. Here it has come down. minus modulus is in this way. And when you have a minus modulus plus sum, so every time when it is plus, the graph goes up, displays up along the y-axis. When it is minus, it goes down. When it is minus, it goes down. It goes down. So even though when I mention this, you are just listening for the first, like you are listening, like you are hearing this for the very first time in your entire academic career. It's not the first time that you are learning this. If you can remember in O levels, you had to sketch the graph of y equals x minus 1 squared. When using this, you deduce x minus 1 squared plus 2. Can you remember? Hands up who can remember something. I don't know whether that has been taken out from the syllabus. So here, first you have to sketch this one. And then you got the graph, it goes in this way. And when the question, let's say Roman number 4 says, using this one, deduce the graph x minus 1 squared plus 2, then what did you do? This same graph was displaced by 2 units. Was in this way. So that is the same thing what I used here. So here if it is a minus, this goes down. If you are supposed to deduce minus 1, this one goes down. So same thing, a modulus plus comes up, modulus minus goes down. Okay, then I'll give you 1 minute if there's anything you can note this down. Just note this down, and anything you want to note in the previous questions you can do. So there's one more thing I need to explain, and then we can do a few more questions. Okay, then write this as a subtopic. Write this. Mathematical properties. Write this mathematical properties. Mathematical properties of a modulus function. Mathematical properties of a modulus function. Mathematical properties of a modulus function. Okay, so first one is now if you have a product inside a modulus, now let's say we are having minus 2 into 3, which is equal to minus 6. What is the modulus of minus 6? It's tell me, what is the modulus of minus 6? It's 6. And if you split this into 2, okay, I'm writing this into minus 2 modulus into modulus 3. Minus 2 modulus is 2, minus 3 modulus is 3. So again, you get the answer 6. So when we have a product inside the modulus, it can be split into 2 modulus, modulus A into modulus B. So modulus AB is equal to modulus A into modulus B, which means the modulus of a product is equal to the product of the modulus. The modulus of a product is equal to the product of the modulus functions. Clear? The modulus of a product is equal to the product of the modulus. Clear? Okay, so write number 1 using a normal pen. Write this, the modulus of a product, the modulus of a product, modulus of a product is equal to the product of is equal to the product of the two. So here, like I'm going to mention the plural of modulus. So the plural of modulus. Anyone who knows that? Modulus. No, not modulus. What is the plural of modulus? So there are different plurals. No, when it is a vertex, the mathematical terms, what is the plural of vertex? Vertexes. Texas. What is the plural of vertex? It's vertices. Can you remember? So same way, like they are having different plurals. The plural of modulus is moduli. Okay, the mathematical plural of modulus is moduli. So like nothing, anything new. So is that something different? No, එහෙම එකක් නෙමෙයි. Moduli කිව්වහම not like this. So we are referring into two modulus. Clear? So I'm just giving that name. So okay, silence. The modulus of a product is equal to the product of the two moduli within bracket, clear the plural of modulus. So write that, write that. The, the modulus of a product is equal to the product of the two moduli within brackets, plural of modulus. Plural of modulus. And then under that one, in the middle of the book, write this using a black pen. Modulus AB is equal to modulus A into modulus B. Okay, so just write this, that's all. And then the second one, so I told you, like, tell me how many mathematical operations you know. How many mathematical operations you know? 5, 6, only 4. You must have known the words, but only you know 4 mathematical operations. පොඩි කාලේ ඉඳන් maths ඉගෙන ගත්තා 4යි කරේ. You know the addition, subtraction, division, and the multiplication. So even in that one, I told you, even inside those 4 mathematical operations, there are only 2 operations. Because a subtraction can be written as addition, and even a division can be written as a product or a multiplication. Division එකක් ලියන්න පුළුවන් multiplication එකක් විදිහට. So any quality or any property that is valid for a multiplication is even valid for a division. I gave that in basic mathematical concepts, if you can remember, when we were specially working with the square roots. If there is a property that is applicable for a product, that is even applicable for a division. So even here, when we have the modulus of division between two, it's equal to the division of the two moduli. It's equal to the division of the two moduli. Is it clear? Okay. Then write number 2, the second fact. The second fact, like this, the modulus of the division of two terms, the modulus of the division of two terms can be written as the division between the two moduli. Can be written as the division between the two moduli. And then in the same way, write this modulus A over B is equal to modulus A over modulus B. Okay, so even though the product and the division can be splitted in this way, the addition and the difference can't be separated. For example, there's no any mathematical fact that modulus A plus B is equal to modulus A plus modulus B. There's nothing like that, because there are instances where this is correct and there are instances where this is wrong. If I show you 3 plus 2 modulus is equal to 5, and even if you split this, you get it is equal to it is equal to 5. You get the same answer. And now let's say you are having 3 plus minus 2, which is actually equal to modulus 1 and equal to 1. But if you split this into two terms, modulus 3 plus modulus minus 2, which is equal to 3 plus 2, which is equal to 5. So it's wrong. Okay, so like you might say, okay, so if it is positive, it is correct. If it is negative, it is not correct. Okay, then I admit, but why do we have to have a mathematical property only when positive that is correct, when it is negative, it is wrong? එහෙම දෙන්නේ නැහැ. දෙනවා නම් ඕන එක්කට හරි. So we write mathematical properties if it is correct for everything, any real number. We don't separate only for positive numbers, only for negative numbers. So here, there's nothing like that. The addition or a difference can be splitted. We don't talk about that because I can't say it's wrong. Can you understand that? I'm not telling that it is wrong. There are instances it's correct, and meanwhile, there are instances it's wrong. Hey, කොටුපුරෝ නම් මොනවද කරන්නේ? මාත් එන්නද කතරයක් කපන්න? Okay, so I'm not telling that this is wrong. There are instances where this is correct, but there are instances where this is wrong. So in general, we don't talk about that we are going to split. We don't talk about that we are going to split addition over difference of modulus. Clear? So I'm not going to write it. Okay. So, okay, I'm asking a question. In a previous lesson, let's say 3-4 months back, I left one page or half a page mentioning that I will be doing this in the future after we do modulus functions. Okay, so I left one page or half a page mentioning I'll be coming back to this page or the concept that we wanted to discuss after the completion of modulus functions. Hands up, anyone, at least if you can remember the lesson, hands up, what is the lesson that we kept that page? Good. So what was the lesson? Inequalities. Did you say that? No. Yeah. Inequality. Yeah. So in inequalities, when you ask me the question, sir, can we square the both sides of inequality? I told you we'll be addressing that one. Okay. Then don't. So we will be addressing that one after we do modulus functions. Okay, so I'll give the note under this one, but when you go home, if you still have the inequalities note with you, just like find the note and then you can write the same note in the page. I don't think that I gave, I asked you to keep one page or half a page, you can complete that. So the question we had is, if A is greater than B, can we square the both sides of the inequality to say that A squared is greater than B squared? Okay. So then hands up if you are telling, okay, this is correct. No one. So no one is telling that if A is greater than B, that A squared is greater than B squared. No one. Because hands up if you are telling this is wrong. There are only two answers. So either it's wrong or either it's correct. Okay, hands up if you are telling this is correct. You can get a chance. I'm not asking whether you want to live or no or die. I'm not asking a question. Simple question. Yes or no? Okay, hands up if you are telling, okay, this is correct. This is correct. Okay, hands up if you are telling this is wrong. Baling mga tusan na kila, we are having like equal amount of students who are telling that this is wrong and correct. Okay, now if a student tell, okay, so this is wrong, I'm giving him an example. Okay, 3 is greater than 2. So when you square this, 3 squared is greater than 2 squared, 9 is greater than 4. So how can you say this is wrong? So how can you say this is wrong? Isn't 3 greater than 2? It is great. Isn't 9 greater than 4? So this is correct. This is 100% correct. You can't say this is wrong. This is correct. So now the students who raised their hand, okay, sir, this is correct. Now they're happy. I see they have now look at this. Now if I, okay, silence. If I take an example that minus 3 is less than 2, this is correct too. Minus 3 is less than 2. You admit it? Okay. And now if I square this, you get 9 is less than 4. Okay, now what happens? Squaring the both sides of inequality now is wrong. මේක වැරදි. වැරදිනේ. It's wrong because minus 3 is less than 2. 9 is not less than 4. And then again, you are having your own assumption. So I got the point. If it is positive numbers, it is correct. But if it is negative numbers, the inequality changes. So you are making your own assumption, and you can even put your name. Let's say your name is Kavindu's theorem. So you are making your own assumption. So this is correct. I got the point. This is correct when it is a positive one, the inequality doesn't change. But when it is a negative, the inequality changes. So soon after you came up with this eureka, that you found this, assuming that you got it, then I'm writing that minus 2 is less than 3. And according to your assumption, if there is a minus, the inequality changes. Now you have assumed that if there is a minus, the inequality changes. And now what happens when you square both? 4 is less than 9. It's correct. It's correct, no? When you are getting the feeling whether you know maths. Even I get that some questions when students ask some questions, especially in 2027 class. In 26, they don't ask questions. Okay, like if you have any questions, ask me. Did you understood this one? Because that one is less numbers in the 2026. So when I go, I'm asking questions by force. Did you understood this? Because I want them to ask questions. But 27, they're asking questions whether you can do bio and maths together. How can you get into NASA? So you're asking those questions. So when some students are asking questions, I doubt about my maths knowledge. I doubt whether I know maths. Maths because I have that one. So here, now you must be thinking, okay, now I made my own assumption that when it is negative, the sign changes, but same thing happen, it is negative, but the sign doesn't change. So now there's no any assumptions like this. There's only one rule about squaring an inequality. So there is only one rule about squaring an inequality. The rule is, look at this. You can square both sides of an inequality. If A equals B, you can square both sides of an inequality. A squared is greater than B squared. But there is a condition only if modulus A is greater than modulus B. So this is the condition. So I'll write the examples. 3 is greater than 2. Is modulus 3 greater than modulus 2? Is modulus 3 greater than modulus 3? Yes, sir. Modulus 3 is greater than modulus 2. Modulus 3 is greater than modulus 2. And then you can square. Then you can square both sides. 3 squared is greater than 2 squared. You are ending up with the correct answer. And now let's say you are writing that 3 is greater than minus 2. Now tell me whether modulus 3, is it greater than modulus minus 2? Yes, it's greater. A modulus 3, it's greater than modulus. If the modulus is greater, then you can square it. Again, when you square it, you are ending up with a correct answer. 9 is greater than 4. You are ending up with the correct answer. 9 is greater than 4. And now, if I write something like this, that 2 is greater than minus 3, but it's clear that modulus 2, tell me, is modulus 2 greater than modulus 3? Modulus minus 3. Is modulus 2 greater than modulus minus 3? Is it greater? No, it's not greater. It's not greater. It's less than. Therefore, you can't square this. If you square this, the inequality changes. So here, you can't change this, you can't square this because modulus 2 is less than modulus minus 3. So can't square. So you can't square this. You can square, but if you square, make sure that you change the sign. That's all. Make sure that you can square this, but make sure you change the sign. In general, I'm telling since modulus 2 is not greater than modulus 3, minus 3, you can't square it. So this is the only condition about square in an inequality. You can square inequality only if the modulus are even satisfying the same inequality. If A is greater than B, this can be written only if modulus A is greater than modulus B. Only if modulus A is greater than modulus B. Okay, so let's write that as the third point. Let's write that as third point. So write in this way. Squaring both sides of an inequality, squaring both sides of an inequality can be only done, can be only done under the following condition. Under the following condition. Okay, then below that one, write in a black pen, write in the exact way. Try this. When A is greater than B, look at the board. When A is greater than B, try this, use a black pen. When A is greater than B, below this one, A squared is greater than B squared. A squared is greater than B squared. Write this in a red pen. Only if modulus A is greater than modulus B. Only if modulus A is greater than modulus B. So you can square them and the same inequality will be remained only if the modulus is even in the same one. And then you can write these three examples. 3 is greater than 2. Modulus 3 is greater than 2, so you can square it. You are getting a correct answer. 3 is greater than minus 2. Even modulus 3 is greater than modulus minus 2. So you can square them. You are ending up with the correct answer. But here, modulus 2 is not greater than modulus 3, which means you can't square. Even when you square, you are ending up with the wrong answer. So here you can write both can't square or inequality changes while squaring. Inequality changes if squared. So you can write both. You can say that you can't square it, or you can square it, but make sure that the inequality changes. Inequality changes if squared. You can take a break and come by 5:40. Okay. Okay, silence. Just, okay, silence. I'm sorry for taking more time. Like today is the okay. Today is the last day of the 2025 paper class. So like it's the last day that I'm seeing the paper panel members who are for this 2025. So I had to go to talk to them. So that's why I just took 10 minutes more. So here, like we discussed about the properties, mathematical properties related to a modulus functions. And now write this as a note, put a in a black pen, write note, and in front of that, use in a red pen. In a black pen, write note, and in front of that, use in a red pen, write this. Write this. A modulus inequality, a modulus inequality can be rearranged, can be rearranged can be rearranged according to the can be rearranged according to the graphs sketched. According to the graphs, you can just write sketched or we have sketched. According to the graphs, we have sketched. Okay, so what did I want to mention is we can change modulus inequalities without doing a mathematical error. So let's say in this way, now you look at the 1993 A-level question. So when you look at the 1993 A-level question, we are having 5 minus modulus x is greater than it. Not this one. Sorry, 1998. I'll come to here. 1998 A-level. So here we got x plus 2 over x minus 3 modulus. It's greater than 4. So this is what I got. So like what we have learned so far, we can't sketch the graph of this. No. It's not possible according to what we have learned to sketch the graph of this one. But what we can do, we learned that the modulus of a division can be written as the division between two modulus. And then, since this is a positive one, you can multiply and you can rearrange the inequality up to this one. So this inequality has been rearranged up to here. And now what you have to do, the same thing that what you have doing since 2 weeks, you can sketch this y equals x plus 2 modulus. You can sketch this one and then you can solve the inequality because here is the initial inequality, but you can change it to a way that you can sketch. You can't sketch this one. So what I do is based on the mathematical properties, what I just learned, it's clear that you can write this as two divisions, a division of two moduli, and then this can be cross multiplied. And this is the inequality that we are going to solve. So after coming to here, this inequality will be solved. This inequality will be solved. This inequality will be solved. And then, if you look at this 2003 question, 2003, yeah. So 2003, you got this. X plus 2 modulus plus x minus 1 modulus is greater than 5. So this is the 2003 question. So according to what we have learned in modulus inequalities, what you can do here, we are supposed to sketch the graphs on the either sides of the inequality. So you have to sketch this one and you have to sketch this one. So according to what we have learned, මොකක්ද කරන්න ඕනේ? Inequality එකේ මේ side එකේ තියෙන එක්කෙනයි මේ side එකේ තියෙන එක්කෙනයි අඳින්න ඕනේ. So you are supposed to sketch this modulus function. Do you know how to sketch this modulus function? We will be learning it next week. If you look at this question number 3, where we have given sketch the following special modulus functions, and you can see under question, I think 7, 8, 9, you get some similar modulus functions. So we will be doing that. But according to the knowledge that you have gained so far, you can't draw this. So what we can do here, we can rearrange the inequality and send in one modulus to this side, and then you can sketch this one and you can sketch this one. So instead of solving this one, I have rearranged the inequality, and I'm getting this one, and then this inequality will be solved. This inequality will be solved. Is it clear? So what did I want to mention is, if you consider the given inequality, we can do a change in it, and you can solve the rearrange inequality. But it can, like, you can't do any mathematical errors. For example, if you do a mistake like this, you take this greater than 2 and you take this to this side, you write it's 2 plus modulus x. So those are wrong. You can't do any mathematical errors, but you can rearrange the given inequality. Okay, hands up if these two are clear. Okay. So under this one, right? So I have given a note under that one, write in this way. Write in this way. Write in this way. The given modulus inequality, the given modulus inequality the given modulus inequality can be rearranged without doing a mathematical error, without making a mathematical error, without making a mathematical error in a way, in a way so what did I mention? The given modulus inequality can be rearranged without making a mathematical error in a way the graphs we are supposed to sketch in a way the graphs we are supposed to sketch are more familiar. The graphs we are supposed to sketch are more familiar. So what did I mention? That we can't say that we are not capable of sketching this, but mathematically you can draw this. Even when we are doing differentiation, a lesson that you have like in let's say 6 months more, in that one we will be sketching graph of this y equals x minus 1 over x squared minus x minus 3 the modulus. So we will be coming up to that stage, but not today. So that if I say that mathematically you can't draw this, that is wrong. You can sketch this. If you can sketch this, this is a more simpler version. So you should be able to sketch this. But according to what you know now, up to now, you can't sketch this. So that's why I want you to convert into a stage that it is more convenient for you, more familiar. This one, by next week, you will be learning how to sketch this. But now, we won't be doing that one. We will be rearranging this up to here and solving this inequality. Is it clear? Okay. Then write this example and then 2003 and then solve the inequality in 2003. Just write 1998 A level under this note. Under this note, write 1998 A levels and come up to this. This inequality will be solved. And then 2003, come up to here and solve it. Sketch the two graphs y equals modulus x plus 2 and y equals 5 minus modulus x minus 1 and then solve the inequality. So 1998 tables come up to here. You don't have to sketch it or solve it. Then write 2003. After rearranging this one, this inequality will be solved and then solve it. Draw the graph of y equals. Do this alone, everyone. I need to see that you have raised your hands when I asked. The do the 2003 question. So when you write the definition of this, you get 5 minus x minus 1, which gives you minus x plus 6. And this becomes plus. So it's x plus 4. So this is when x is greater or equal to 1. This is when x is less than 1. So y equals x plus 2 modulus, that is something that you can easily sketch because we have even done that before. So then y and x, here if you find the turning point, you will get it's 5. So I'll directly draw this. The turning point is 1, 5. The turning point is 1 and 5. So how did I get it? The two straight lines that I'm supposed to sketch is y equals minus x plus 6 and y equals x plus 4. So if you consider x equals 1, y is equal to 5, and even here x equals 1, y is equal to 5. So now, before even sketching the graph, you know it is a minus in front of the modulus. So that's why I told you, before sketching the modulus function of the graph, know the shape of the graph. So you know when it is minus, it's in this way. And you can remember we have given when it is a plus someone, then this minus shape comes up. So you are supposed to get a V-shaped graph, the opposite one which has come up. So here, it goes through this point and the gradient is minus 1 and here the gradient is 1. So what is this? It's y equals x plus 4. And what is this? Y equals minus x plus 6. And then in the same graph, sketch y equals x plus 2 modulus. That is someone you can easily do. The gradients are equal. The gradients are equal. So this goes in this way. The two gradients are equal. So here you get y equals x minus. It's minus, no, it's in this side. It should be in this side. So this is y equals x plus 4. And if you sketch the graph y equals modulus x plus 2, it is going through this minus 2 and x plus 2 goes in this way where the intercept is 2. So you get y equals x plus 2. And here it's minus x minus 2. It goes in this way. This is y equals minus x minus 2. So you have two intersection points. This intersection point is minus 3. And this intersection point, it's 2. Yeah. So then what is the inequality that you're supposed to solve this inequality? The blue colored one is greater. Okay, it's clear. The blue colored one is greater. The blue colored one is greater. In this region, it's greater. In this region, it's greater. Then again, in this region, it's greater. In the intermediate region, it's not great. It goes below the black colored one. You get this one? Okay. This one? Okay. Then when you're writing the answer, so wait, hands up who got these two graphs? Okay. So when you're writing the answer, let's write the answer in this way. So first write the inequality you have solved. Modulus x plus 2 is greater than this one, and then write the inequality they were asking. X plus 2 modulus plus x minus 1 modulus is greater than 5 when. So first write the inequality you have solved and then rearrange it to the way that they have asked and then write the answer that x is less than minus 3 or x is greater than 2. X is less than minus 3 or x is greater than 2. Got the idea? Good. Okay, then do 2018. Yeah, 2018. Question number 19, 2018. Start the question 2018. And if there's anything you want to ask me, the online students, send me a message in the chat. And when you ask it in the chat, make sure that you are watching the online class as a live. You don't have any lag or you are not 20 minutes or 30 minutes back. If not, even when I'm going back to home, I get some of the questions in the chat. So can you again explain this one? So like online students, when you are only if you are following the live video, then only watch, like ask a question. If you have having a lag go like 20 minutes or 30 minutes a delay, then there's no use of asking the question. To 2080. Yeah, like all are good. The class is good. Okay, so first you have been asked to sketch the two graphs. So I'll directly draw this y equals 3 minus modulus x. So now we have sketched more than I think roughly around like 40 modulus functions. So you can directly draw this. 3 minus modulus x goes in this way. Make sure you name it properly. Okay, this is y equals minus x plus 3. And this is y equals x plus 3. The intercept is 3. The next function is x minus 1 modulus. It's going through this 1, 0 point. So this is the shape you get. And don't think about the inequality first. First find the point, the intersection points. So here it's y equals minus x plus 1. And if you find the two intersection points, that you can easily do. Okay, this intersection point is, you get minus 1. Is it minus 1? Yeah. This intersection point, you get it's 2x4, it's 2. No? The two intersection points are minus 1, 2, right? Okay. Okay, hands up who have sketched this graph. Good. So now when you look at this, the inequality is quite different. They have asked you to find that modulus x minus 1 plus modulus x is less or equal to 3. Is less or equal to 3. But normally, normally what we do here is when we have been given a modulus inequality, we sketch the two modulus functions in the both sides of the inequality. But here now, if you look at this, what are the two graphs that I have sketched? One is y equals 3 minus modulus x, and the other one is y equals this. Okay. Okay, now listen, now focus, look at the board, stop writing. One thing that we need to realize, like for example, I'll tell this in this way. So, like we talk about students, like even when after school starts, you already school has started, and when you have been term test, you will realize after the term test marks have been given, you will be see that some students and whatever the term test that you are writing and whatever the paper that you are writing, there will be a few students who have scored more than, let's say, okay, so whatever the exam that you write, you will see, okay, you will see students that who are scoring really good marks. So, for example, even in the 2026 class, there are students, whatever the paper I give, there are few students who score more than 80s. And even like I just got a message, just means in the interval, I got a message, a telegram message from one of the students in the Sinhala medium class 2026. So they have had the school term test. She's from Visakha. So she's like she was the first in almost every exam that we have done in that class. Only once she was second. So in like in almost every exam we have done in that class, we have done so far 5 main papers and overall 18 or 17 papers. So far we have done 23 papers in, so out of 23, 22 papers she was like the first. And now she has sent me the marks of her term test. She's from Visakha. She has got 100 for applied maths and 98 for PO. So the term test mark is 99. Okay, so even back then when I was at school, when I was schooling and doing term test, I even have got 199. But normally in maths, I managed to score more than 95. But in physics and chemistry, it was not more than 90, 95. It was somewhere around 80, 85. But comparatively, that is even really good when you will realize that after you write a term test. So like there are students. So then we come up with this assumption. Okay, we say that these are the bright students. Whatever the exam they write, whatever the question that have been given to them, they are okay. They will be solving that. But from my end, I know because I even used to be at that situation. how I used to solve problems or how I managed to score a good mark above 90, 95 even in school term test is because I don't call it as like being bright or having a high IQ, having a capacity. What I call it as simply it's the experience. Because I have solved so many questions at the end of, let's say, we complete the lesson, modulus functions. So after the end of modulus functions, even when I go home, I work with that. So I have done more than 100 modulus inequality questions. So whatever the question that will be appear on the paper, I have a previous experience. Okay, this is the way that I need to approach the question. Maybe at a glance, I don't get the feeling, okay, this is how I can solve this. Like soon after, when I just read the question, I might not get idea, okay, this is the exact way to solve this. But somehow, when I read that, I get a familiar feeling and I get this feeling, okay, we can do this and let's do this and let's see what happens. So that is what I call as experience. So that's why I'm telling you, like even like if you're going to tell me, like especially the students who have scored good marks, because we had two 90s and 100 in this class. Even if you go and ask from them, like did you like are you working at home, and if that person say no, I don't work at home, I just come to the class and I work and then I go home and I play computer games, I'm totally in YouTube and all, that is lies. Because you can't do it that way. If you're having a good IQ potential, you can still manage to score more than 17 that way, more than 16 that way. But to bring to that mark, you have to work a lot. So that's why I'm asking you, like at the end of, if you can remember, when we gave the marks of the main paper two, I asked you to do something. I don't know whether you have followed that. If you have followed that by now, you have done a few questions because 2 weeks have been gone. Q&A පොඩි දෙයක් කරන්න කියලා. Because we are having the next main paper at the end of November. So I told you to start doing something. Something means not something. I mentioned what is that something. මං කිව්වා ඒක පොඩ පොඩ කරන්න, by the end of November you will be coming to a good level. Okay, so then when you have that experience, when you look at a question that comes to you, okay, this is what I'm supposed to do. So here, even in this question, what I have drawn is this one and this. And we don't get this commercial advertisements in our A-level math questions. There are commercial advertisements. The film में क्या ना film में math एक बार है ना commercial advertisement का. Is there any connection between the film and the commercial advertisement? Is there any connection? No, like those are just paid commercial advertisements. So you are watching the film and then suddenly a few ads come up. If you're watching the film in Hero TV, it's the other way. Like you watch the commercial ads and meanwhile they show the film. In Hero TV, I don't know whether you have watched Hero TV, but in that one, they are normally showing the film in that way. And commercial ads ටික යනවා විනාඩි 20ක් 25ක් විතර. ඊට පස්සේ විනාඩි 5ක් 10ක් විතර ෆිල්ම් එක පොඩ්ඩක් පෙන්නනවා. So, but in normally what we do when we are watching the film, like we see the commercial advertisements, no any connection. අපිට maths ඇතුලේ එහෙම commercial advertisements දෙන්නේ නැහැ. So you must be thinking, okay, I have been asked to sketch two different graphs, but they're asking the question is quite different. No, inside this one, if you rearrange this, you will be able to see these two graphs. So because when we are using the graphical method, when you are supposed to solve this inequality, you have to rearrange this such that you are having the two modulus functions that you have already sketched on both sides of the inequality. So you have to rearrange this inequality in a way that you can clearly see the two modulus functions that you have sketched. So now if you take this as one, okay, on the right hand side you have this first function, and in this as two, in the left hand side you have the second function. Clear? So you have to do that rearrangement. And then you can write, okay, this happens. So this is when modulus x minus 1 is less than this, when, okay, now look at the graph. You need to find this black colored one is greater. The black colored one is greater in this region, and these two have been included. Greater or equal. And then you can write when x is greater or equal to minus 1, less or equal to 2. When x is greater or equal to minus 1, less or equal to 2. So we can write this in this way. So what you have to do when you have been asked to sketch one function, but the inequality is a bit different, you need to rearrange this in a way that you will be seeing the two modulus functions in the both sides or in the two sides of the inequality. Is it clear? Okay. So then write this, rearrange it, and write the answer. Then I'll give a small note, put a red arrow near here. Then I'll give a note. So first complete the work after sketching this. Write in this way. Okay, put a red arrow near here. And then put a red star mark and write in a blue pen. Red arrow, red star, but write in a blue pen. Muking liwat tawlak na same note, but I'm imagining about a note when I give the note. So that's why. So when I'm reading out a note, I have a note in my mind. So I have that imagination. So I'm imagining a red arrow and red star mark and the blue colored pen. If you only have the blue colored pen, write something. Which don't don't wait till you get a red pen. Okay, write it this way. When the modulus inequality we are supposed to solve, when a modulus inequality we are supposed to solve, is different different from the modulus functions is different from the modulus functions we have sketched comma we need to rearrange the inequality. We need to rearrange the inequality. We need to rearrange the inequality in a way the two modulus functions we have sketched. The two modulus functions we have sketched is in the two sides, are in the two sides of the inequality. Are in the two sides of the inequality. So what did I mention? That you need to rearrange this such that the two modulus functions that you have sketched are in the two sides of the inequality. So here we have x minus 1 modulus. Here we have 3 minus modulus x. Okay. And then towards the right hand side, just write this one. Towards the right hand side of the book, put a small note. And these two factors. Modulus a minus b is equal to modulus b minus a. Towards the right hand side of the book, you can just put this note and write this. Modulus a minus b is equal to modulus b minus a. Because there is no any change when there is minus, no? Because modulus 2 is equal to modulus minus 2. So whatever, like even you change these two, it's equal. Towards the right hand side, පොතේ දකුණු පැත්තට වෙන්න මෙන්න මෙතන මෙහෙම නිකන් නෝට් එකක් කියලා දාලා මෙන්න මෙතන යන්න. You can write it in the left hand side. These are not rules or orders. මම දකුණෙන් ලියන්න ගොම් දකුණෙන්ම ලියන්න ඕනේ නෑ. It's not like you are walking on the road. No, you're supposed to use the right hand. So write wherever you have space. දකුණෙන්ම ගන්න ඕනේ නෑ. මොකද එකපාරක් මං කිව්වා මේ දකුණු පැත්තෙන් අඟල් දෙකක් විතර තියලා I have seen students keeping 2 inches, measuring 2 inches and then putting it. වෙන්න ඕනේ නෑ. Common sense. You're doing maths, no? Not arts. Not that our students don't have common sense. So a minus b modulus is equal to b minus a modulus. And the other one is if you have like, okay, silence. 2 times modulus a, 2 can be taken out. It's 2 times modulus a. So you can take out this 2, 3 or the numerical values out of the modulus. So just write these two. Modulus a minus b is equal to b minus a. And if you have something like modulus 2a it can be written as 2 times modulus A. Okay, now do the 2023 question. To the 2023. So first draw the two graphs that they have given. And then the inequality is a bit different, but you can rearrange the inequality in a way that you can clearly see the two modulus functions. The two modulus functions. So do 2023, if there's anything you can ask from me. Same thing now, first sketch the two modulus functions that they have given. And then take the inequality and rearrange it in a way that you have in the two graphs. So first, when you have been given to sketch a graph, then sketch it and then look at the inequality. Don't look at the inequality and sketch the graph because they have given clear instructions. First, sketch the graph of these two. So first do that one and then look at the inequality. So I told you we don't get commercial advertisements. So check how you can rearrange the modulus inequality in a way that the two functions will be coming in the both sides. Okay, silent, silent. හොඳයි කිව්වා විතරයි පොටින්ද. So first, they have given clear instructions to draw these two. Y equals half modulus x plus 1 and 2x minus 1. 2023 A levels. So what are the two graphs that you are supposed to sketch? Is y equals half x plus 1 modulus, which gives you half x plus half and minus half x minus 1. But here when x is greater or equal to minus 1 and x is less than minus 1. Only if you are a newcomer, it's okay that you haven't sketched the graph. If not, everyone else should be able to sketch the two graphs. That's normal. So here you get 2x minus 1 and minus 2x minus 1. That is when x is greater or equal to 0. So it's like 2x is greater than 0. When 2x is greater than 0, you get x is greater than 0. So now I'll draw this. So we can find the turning points here. The turning point becomes 0, minus 1. And even here it's 0, minus 1. And you know when it is a modulus graph, only a modulus, it will be on the x-axis. No? On the x-axis, this one will be going below the x-axis. So that is the advantage of knowing the rough sketch that you get. Here, it is something that is on the x-axis. Here, it is going below the x-axis because minus. So then you can draw the straight lines in this way. So there should be a clear gradient change because half and 2. No? This is at minus 1, half x plus half. And it's in this way. Name it y equals half x plus half. Silence, silence. Y equals minus half x minus half. And then the other thing is this 2x minus half. It's going through this point minus 1. And then the gradient is 2, which means it's much greater than this. From other end, this one, it goes in this. So this is the graph that you're supposed to get. This is y equals 2x minus 1. Or y equals minus 2x plus 1. Sorry, minus 1. Okay, hands up who would read this. Everyone, hands up. Who got this? Okay, so even who are join online, send me a message, everyone. The reply count and the participant count should be the same. If not, I'm going to end the live. So send me a message, everyone, if you have got this properly, send it. Okay, so before thinking about the... silence. Okay, so before... Okay. Before moving on to the inequality, find the intersection point. So I'll get the answer from you. So what is this intersection point? Minus 3/5. Minus 3/5, is it 3/2? Yeah, okay. So this one, you get 2x half 3/2. It's 1. No? Okay, so you get these two intersection points, minus 3/5 and 1. That you can find if you feel that this is a bit difficult. What are the two lines that have been intersected? Minus 2x minus 1 and y equals half x plus half. So when you make these two equal, silence. So tell me, what is the best way to simplify this? So what is the best way to simplify this? So what makes this a bit not complex, but rather than simplifying a normal equation, what troubles you here is divided by 2. So what is the best way to simplify this? You can multiply by 2. I admit you can take this minus 1 here and half here, but the reason that troubles you here is this divided by 2. So when you multiply by 2, you get minus 4x minus 2 is equal to x plus 1. So you get minus 4x minus x is equal to 1 plus 2, which gives you minus 5x is equal to 3. So you can do the simplification even by taking minus 1 here, plus 1, that's okay. But if you multiply by 2, you can take out this divided by 2. Now it is clear. So I told you, you don't get A-level questions as commercial advertisements. No. So look at this inequality. The inequality they have given is 4x. So this is the inequality we have to solve. 4x minus x plus 1 is less than or equal to 2. So first thing, when I was walking, I got the question from students, sir, how can we think the question from this side? No. First, follow the instructions. You have been clearly asked to sketch these two graphs. Is it clear? First, draw that. Then look at the inequality. First, draw the two graphs that they have asked and then look at the inequality. Okay, so how can we think this? So here, it's clear that what we got is modulus 2x minus 1. And this x plus 1 modulus is isolated. So there should be one point that we need to think. So what is my thinking point? X plus 1 modulus, x plus 1 modulus is isolated. So here, the first thing that I'm going to do, I'm going to isolate x plus 1 modulus. So here, take this to this side and write this in this way. Minus 2 is less or equal to this. So what did I do? I isolated x plus 1. And now tell me, what is missing in the graph that we have sketched and what is missing in here? Don't look at this side. දෙපැත්තෙන් බැලලා වැඩේ කරන්න බෑ. එක පැත්තක් බලන්න අනිත් පැත්ත නිකම්ම solve වෙනවා. So I have mentioned that before. In maths, let's say you have a doubt about two sides. You can't just look at this side and even look at this side and then no, not in that way. You're not crossing the road. So always when you're having two doubts, just focus one doubt. Focus on one problem. Then when you are going to solve that one, automatically the other one solves. So if you think both these sides, if you look at these both sides at the same moment, it's a bit tough. It's a bit tough to think what you're supposed to do. So here you have modulus A. You have modulus x plus 1. Now tell me, what is missing here in terms of the graph that we have sketched? Tell me, the class, tell me what is missing. In terms of the graph that we have sketched, here, this one and this one, what is missing? Half. So how can you get a half here? By dividing by 2. Can't we divide an inequality by 2? Can or can't? Sure, ne? Can or can't? We can divide an inequality by, we can divide the both sides of inequality by a talk. I need to discuss. we can divide both sides of an inequality, not half, make it half. I'm asking in general, by a positive number. Why can't we divide by a negative number? We can, but we need to make sure when you are dividing by a negative number, the side change. So there's no any rule that we can only divide inequality by a positive. No, you can divide by any number, but when it is positive, the sign remains unchanged. When it is negative, the sign changes. There is only one instance that you can't divide an inequality. You can't divide an inequality. So now you tell me, if you know that the number is positive, you know the sign won't change. And you know when the sign is negative, you know that when the number is negative, you know the sign changes. So if you don't know the sign, if you don't know whether it is positive or negative, then you can't divide. Then you can't divide because when you don't know the sign, you can't divide. We have discussed those. So here you can easily divide by 2. So I'm only focusing this side. I'm only focusing this side. දෙපැත්තම හිතන්න යන්න එපා. So when you divide by 2, it's 2 modulus x minus 1 and you get half this. And that's why I gave you a separate note. If there is a 2 inside, you can take it out. If there is a 2 outside, it can be sent in. So this is modulus 2x minus 1 is this. Clear? So this one can be arranged to a step where you can clearly see that you have been asked the blue colored one is less than the black colored one. You are supposed to find the range that the black colored graph is greater than the blue colored one. So when you come up to here, okay, then you can write the answer. The black colored one should be greater than the blue colored one. The black colored one should be greater than the blue colored one, and the equality is accepted. Okay, then you can write the answer. This is when x is greater than or equal to 3 over 5, but less or equal to what? So here, you need to bring this up to here. You need to bring this up to here, 2023. Okay, so hands up who rearrange this inequality up to here. Okay, hands up who understood that. Okay, so complete the work. So I'll give you how the marks have been given in the exact marking scheme. Okay, so marks have been given. So I'm referring to the exact marking scheme. Wait, silence, silence. For this one, black colored graph 5, blue colored one 5. To find in both the intersection points, you get 5. And yeah, to rearrange in this inequality up to here, you get 5. And to your final answer, you get 5. Okay, so this is how you get marks in a A-level paper. Clear? Okay, so then mark these questions as homework. Okay. Wait, so mark these questions. Silence. Silence, stop. Stop talking. Okay, mark these questions. On the past papers, first complete all the 18 questions. Under question number 2, complete all the 18 questions. Question number 2, complete all the 18 questions. And in past papers, first do all first 10 questions. First 10 questions except 4 and 5. So past papers except 4 and 5, do the first 10 questions. And then 2018 that we have done, 2018 we did, to do all the, yeah. So after marking the first 10 questions except 4 and 5, mark these questions, 2004, 2005, 2004, 2005. Yeah, I think that's all. Okay. You can get ready to go. Okay, now silence. Okay, now stop talking. So even though, sorry, so I need like exactly 5 minutes. Even though I have mentioning about that something that you are supposed to do, I haven't mentioned about the something. No, something එක මොකක්ද කියලා කිව්වද? Did I say that? No. So like when I went, few students tell me, say, what is that something? මම කියලා නෑ something එක මොකක්ද කියලා. So this is what you have to do. So I'm not asking, wait. I'm not asking you to do this till the end of A levels or till the end of this year or till the, let's say, till grade 12. What I'm only expecting from you is do this exactly in the way till the end of November. So I don't want a consistency from you for like 1 year, 1.5 years. එච්චර කල් ඕනේ නැහැ. I'm giving you a small task, and then what I want you to do is do this till end of November. So what is the small task? By now, I think you all have done the main paper again. I ask you to do that. That I ask you. That is not something that I ask you. So you are supposed to have it with you now. මම කිව්වා යද්දි ඒක මම කිව්වා you should have it. So first thing that you need to do the main paper again. So when you wait, focus. You need to do the main paper again and then compare the 2 marks. Let's say you got 60 to the paper, but now when you do it at home, you get 85. So 85 is your real mark. 85 is your real mark. But why did you end up taking 60? That is because of a simplification error, or you could manage the time in the given time period. You were not able to complete the paper. Because of those reasons, your 85 has become 60. But 85 is the mark that you can get from your knowledge. So then you have to focus on the remaining 15. You are not focusing on the remaining 40 marks. Let's say for the exam you got 60. So you are not focusing on 40 because only you are lacking of 15 marks. So you have to first focus on that 15 marks and think why couldn't I get this 15 marks? ඒ ලකුණු 15 ගන්න උනේ කියලා බැරි උනේ කියලා බලන්න. Number one thing, you need to cover that part. Let's say you can't remember how to split a rational function into partial fractions when it is when the degrees of the degree of the numerator is higher. You can't remember that. Or when you are having a denominator like x plus 2 to the 7th power, you can't remember that. Let's say you can't remember that. So if you can't remember, then you have to cover those 15 marks. You have to cover those 15 marks, and now then your knowledge is up to 100. Because we have to admit, like, anyone who comes with taking 100 marks of, like, who's having a knowledge of 100 marks, very rarely they end up with taking 100 marks. Normally it can be vary from 60, 70, 18, that when maybe it can be even more less. So what is the first thing? You have to mark the areas that you can't remember, or that you don't know, you can't, let's say you can't remember, and you have to cover that one. And what I'm expecting you now from here onward, from today onwards, we got 6 weeks till the end of November. So you're having 6 weeks for the next main paper. Take this main paper as your school term test paper, because most of the schools are having a term test in December. After the vacation, most of the schools are going to have a term test. So make this one work for this one as a term test. So this is what you only have to do. These are the lessons that we have done. You can take out basic mathematical functions. So what I want you to do, not me, is you have to do a minimum of 5 questions from each of these unit per week, not per day. Not per day, okay? Per week, what I want you to do, a minimum of 5 questions. So when you are selecting that 5 questions, let's say you are taking a polynomial question, find the remainder when this function is divided by x minus 1. ඔය වගේ සීනි බෝල ප්‍රශ්න නෙමෙයි. So when I'm referring to a polynomials question, that should be a proper past paper level or a similar level question. Not like find the remainder when this is divided by x minus 1. X equals 1 dollar, you get the answer. And you are satisfied. You do 5 of those questions and you do it for 6 weeks. You do 30 of those questions and you come to the exam. You are not able to do the polynomials question and you are complaining me, sir, man sati 6 me kara polynomials ප්‍රශ්න 30ක් kara, but still I couldn't do the question in the paper. So when I was asking, okay, what are the questions you did? You have been finding the remainders, factors in that. No, all should be past paper level questions. Then do 5 inequalities, good inequalities. And then partial fractions. When you're doing five partial fractions, do at least 2, 3 normal rational functions and 2, 3 rational functions where the denominator is higher. Sorry, the numerator's degree is higher. Functions, do proper 5 questions and make sure you know how to find the range, codomain, the domain, inverse functions. And then modulus function is what we have been doing for these 3 weeks and recurring decimals. So that's all I'm expecting from you. What you have to do is you have to do 5 questions from each these units. If you are a newcomer, that's okay. Let's say you started from here. That's okay. Just focus on that. But I have given them a plan how to cover this one. Okay, so only do 5 questions. කීයක් කරන්න ඕනේද? Only 5 questions from each unit a day or per week. Per month. යන්න හදිසිද? ෆ්ලයිට් එක දැන් නෑනේ. අද නෙමෙයි යන්නේ රටනේ. හරි. හරි. ගොඩක් කරනවා කියන්නේ ෆ්ලයිට් එකට. So, okay. So, only 5 questions per week. Wait. I'm not asking you to plant these Chinese bamboo trees. Have you heard about this Chinese bamboo tree? චීන උණ ගහ කියන එක අහලා තියෙනවද? So Chinese bamboo tree is is something like this. What you have to do, you plant a seed of a Chinese bamboo tree and you keep watering that bamboo tree. But you won't be seeing at least a part of that seed, any leaf coming out of the soil for almost like 3 years. For 3 years, you will be watering, you will be putting these fertilizers, but you won't see a result. But soon after 3 years, when it comes up in a time span less than 3 months, that Chinese bamboo tree will be growing up to 30 yards. So till 3 years, no any result, but you have to continuously keep watering and putting fertilizers. You won't see any result. No any result. The reason, there is a result, but you can't see the result because it is not growing up. The tree has been growing down. The tree has been growing down, making his foundation, properly grounding with the roots and all. And soon after 3 years, it comes up. In less than a time span of 3 months, it goes up to 30 yards in three months. So I'm not expecting you to do something that you don't see the result for 3 years. I'm not asking you to plant a Chinese bamboo tree. I'm only asking you to do this for how many weeks? 6 weeks. And if you get the result after 6 weeks, if you see a clear result after 6 weeks when you do the main paper 3, then I don't have to ask you, I don't have to repeat you to do this and again. Because when you do something, when you see the result, automatically you will be doing that. Because you know, okay, this is the thing that we need to do. If you do something and if you see the result, you do that. You continuously do that. Then I don't have to මට මෙහෙම කෑග ගහින්න ඕනේ 5ක් කරන්න 4ක් කරන්න කියලා. I don't have to repeat it. So that's why I'm only asking you, have this consistency only for 6 weeks. මේ සති 6 පන්න ගන්න පුළුවන් කියලා කියන්නේ you will be doing it again and again. Okay, if there's anyone who do this properly for 6 weeks and still there is no any improvement of his or her marks, that means, being honest, you haven't done it properly. Because I haven't received any of the complaint from these 5 years from any of the students. So I honestly did this, but still my marks is not improved. Because you have to be honest to yourself and do it for 6 weeks, and that will be great. So this is the something that I mentioned. Clear? Understood? Balankincha. Understood. Okay. And I later learned that Balankicha means තේරුණාද. ඔයගොල්ලෝ ඉගෙන ගන්න හොඳයි දෙමළ යාළු ඉන්නවා නම්. Balankicha means kicha is kinchan. What? තේරුණාද? Did you understand? තේරුණා කියලා කියන්නේ Balankichi. Balankichi, no, it's Balankichi that I understood. Yeah, good. Okay, so we are done for today. You can go home safe. Yeah.